Okay, so moving on. A continuous random variable has probability density function as shown. Given that the mode is 1, show that A equals to B. Okay, so the first thing I see is mode is 1, and in my head I know straight away to find the mode of a probability density function, to find the mode of a continuous random variable, I'm going to need to differentiate the probability density function. So I'm sure that that's going to be our first step. There's two unknowns here, but I'm trying to show how they're related to each other. But let's go ahead and differentiate. Okay, so for the first term, the x term is going to disappear. I'll be left with the constant a. And for the second one, just differentiating as we usually would, and I've got the coefficient negative 2b. This is looking promising already since I've generated the 2 which I was asked to show. Let's just see if this follows through. So that's the expression when I differentiate. Well, the mode is when the gradient function equals 0. So I now have the gradient function. I'm going to set it equal to 0, and I've been told that the mode is actually 1, so I'm going to substitute 1 into here, and this statement should hold true. So a minus 2b with 1 substituted in equals 0, and I can see it rearranging from here gets me a equals 2b. All right, a nice little 2 marks there. Okay, nice little 2 marks there. I saw that we were looking for the mode, so straight away I knew to differentiate, and then I just used the value that I was given in the question, that when the x value is 1, that is how I get the mode, and obviously the mode is the gradient function set equal to 0. Okay, next I was asked to find the value of A and the value of B. So looking at a continuous random variable again, there's other things that I know should occur straight away. Firstly, I know that if I integrate in between the maximum value and the minimum value, I should get an answer of 1. So let's go ahead and do that. And since I could always eliminate one of those terms, I think that should be good enough for us to generate an expression for A. That should be good enough for us to find the value for A and the value for B. All right, so integrating in between the largest and the smallest limits should always equal 1. So integrating between 2 and 0, ax minus bx squared should equal 1. Okay, so 2 substituted into the first term is going to give me 2a. Substituted into the second term, and 0 substituted into those terms is just going to be 0. Okay, so that's the expression that I have that I know should be equal to 1. So 2a minus a over 3b equals 1. I actually know that a equals 2b, so let me just substitute that in right now. So I've got 2 lots of 2b minus a over 3b. Okay, so that leads to 4 over 3b equals 1. And from there we can see that b is going to equal 3 over 4. Okay, and if b equals 3 over 4, and I know that a is 2 times b, that means that a should equal twice 3 over 4. A is going to be 3 over 2. All right, good stuff. Okay, calculate the cumulative frequency of 1.5. So the probability that it's less than or equal to 1.5. This is a 2 marker. So do I need to do the whole CDF? The question hasn't asked for it. So we can use the second way of finding a cumulative distribution, which is just to integrate in between the lowest value and the value that I'm looking for. There's a general result that I'm referring to, so let's go ahead and do that. We've already integrated, so I'm just going to use that integration function straight away. Okay, so that's the expression that I'm going to need to use, and I'm going to substitute in my 1.5 and a 0. I actually know what a and b are, so I'm going to put those in as well before I do my substitution of 1.5. I'm just going to do one step at a time just to avoid any confusion. So that's going to end up being 3 over 4 x squared, and if I substitute b in, that gets me 1/4 of x cubed. All right, and I do see a chance to take out that quarter just so I can quickly check answers in my head. Okay, so what's this going to lead to? When I substitute 1.5, okay, so what's this going to lead to? When I substitute 1.5 into the first term, get 27 over 4. And when I substitute it into the second term, 27 over 8. 27 over 4 minus 27 over 8 is just going to be 27 over 8. And multiplying those together, 27 over 32, or if you prefer the decimal, 0.8438 to 4 decimal places. Okay, so for part C here, we could have gone ahead and found the whole cumulative distribution, but don't forget, we're not just fighting for accuracy in the exam, we're fighting for efficiency as well. So just trying to be as quick and sensible with the techniques that we're going to employ as we can. Okay, so lastly, we're asked to state whether the upper quartile of x is greater than 1.5, equal to 1.5, or less than 1.5, given a reason for our answer. Well, in my head, I've got a diagram, and whatever the distribution looks like, I know that the probability below 1.5 is 0.8438. The probability below the upper quartile needed to be 0.75. So I'll assume it would have been somewhere around about here, meaning that the upper quartile is going to be lower than 1.5. All right, and this is my response. So the upper quartile Q3 is going to be less than 1.5, since the probability of being less than the upper quartile, that's 0.75, is less than the probability that x is less than 1.5, which was the 0.8438. Okay, diagram clarified it for me, and a sensible statement here is what's going to get you your final marks.